Hello everyone, welcome back to another remote sensing lecture video. And in this lecture video, I want to continue our discussion on the image-to-image types of change detection by talking about image differencing and going through an example. So give ourselves a little bit of room here. Let's talk about image differencing. Right. So image differencing, again, as we mentioned in the previous video, is just this idea that we subtract one image from another. Okay. So what I want to do, because this is a pretty straightforward definition here, is I want to actually walk through an example that is going to be conceptually very similar to what you're going to be doing in this week's lab. And what I want to do is I want to set up two NDVI images. So we have NDVI at time 1, and we have NDVI at time 2. All right, and we're going to have a very small subset of imagery where we're going to have 4 pixels. Okay. And sort of to set the stage here. All right, let's set the stage here. These are, at time 1, this is going to be heavily forested. Right, so the NDVI values are going to be quite high. So let's do, say, 0.8, 0.9, 1, except for this area. This area is going to be moderately forested, so we would say maybe this is a value of 0.2. All right, so NDVI at time 2, let's say a fire came through. Right, a fire burned through these 2 pixels here. All right, so now let's say these are basically bare soil. So it burned through here and it's going to make this negative 0.8, and it's going to make this, let's say, how about we go all the way to negative 1 here? Right, it didn't affect this much. Let's say maybe it burned a little bit of this pixel, so we'll say this is now 0.8. And it didn't do anything to this pixel, so this pixel is still 0.2. Okay? So this is a fire burning through. Now, because we're using NDVI, right, we don't want negatives, right? So subtract one image from another. We don't want negatives, right? Because again, a positive minus a negative, you end up with a larger number, so it kind of messes with results here. So we don't want negatives. So what we're going to do is we're going to actually add 1, and we're going to add 1. So that way, NDVI, which normally ranges from -1 to 1, will then range from 0 to 2. So 0 would mean like bare soil or really, really, really bad landscape. 2 would mean pristine vegetation, right? That's how we interpret NDVI. We've talked about this before. So if we add 1, right, this becomes 1.8. This becomes 2, this becomes 1.9, this becomes 1.2. Okay, so we add 1 here. Right, this becomes 1 plus negative 0.8, this becomes 0.2. Right, this becomes 1.8. This becomes 0, and this becomes 1.2. right? So what we do is then we subtract, right? We take the difference, right? Image differencing, right? We take the difference, we subtract time 1 from time 2, right? So t2 minus t1. And so what I want to do is first do the subtraction and then figure out how we can kind of deal with this. Okay, so let's take this first pixel here. So time 2 is 0.2, right? Time 1 is 1.8, so subtract 1.8. Right? If we do that, we get a value of negative 1.6. Right, this one over here, we have 1.8. Let's move it over here a little bit so there's no confusion. Right, we have 1.8 minus 2, right, because we're taking time 2 minus time 1, and we get a value of negative 0.2. Right, here we go 0, 1.9, right, we get negative 1.9. And then over here, right, we get 1.2 minus 1.2, giving us 0. Okay, so what I want to do now is I want to talk about what we do with this output. I'm going to give us a little more room here. And I want us to think about two scenarios, right? The first is to take this and make a change, no change, right? The most basic version of change detection. How would you go about doing that? Well, the way that I would approach this and the way that most people would approach this would be to pick a threshold. All right, so let's say maybe the absolute value of 0.5. Meaning, right, if the value in the difference is greater than 0.5 or less than negative 0.5, it's change. So let's take a look at this, our example image here. And let's figure out if it's change or no change. And we're going to do green for change, and we're going to do red for no change. Right, this is the same thing we did before. Right, so if we have change, if it's greater than the absolute value of 0.5, negative 1.6 is less than negative 0.5, so we have change here. Oop. Sorry, we have change here. Right, negative 0.2, right? That's greater than negative 0.5, but it's less than 0.5, so it's within our threshold of no change. So this would be no change. All right, 0 is obviously less than our threshold, so that also is no change. And then negative 1.9 is definitely outside of our threshold, so that's change. Okay, so one thing to do would be to pick a threshold, right? Pick a value of the difference beyond which we say we have change and within which we don't. Now, this threshold, you have to be careful, right? You have to sort of support how you pick it. Right? Look in the literature, look at your images, figure out, okay, what threshold makes sense for me to turn this continuous image here into a change, no change. Okay? That's one method. another method, I'm going to give myself up a little bit and give myself a little bit of room this way. Instead of doing change, no change, is to actually do magnitude of change. You know what? I'm actually going to stop the video here because I want to make this interpretation its own video, because I want to make absolutely certain that we understand, that we have time to sort of think about everything. So let's go ahead and stop the video here, and we're going to pick up on magnitude of change in the next video. So just to recap what we've talked about, right, we discussed this idea that we could do image differencing by subtracting one image from another. And then we went through the example of NDVI, which we had to make all positive first. And then we sort of said that we could pick a threshold based on some literature or some exploration to convert these values to change, no change. So hopefully that all made sense. And if you have any questions, please reach out. Thank you.